presentations for the 2016-2017 NASA in-world OPSPARC final design reviews. Today we're going to first hear from Team 2. Team leader David is here with us. David, will you please help us get to your team world?
Hi everyone, can you all hear me? Okay, great. So if you would go to the tabs window on the left side of your screen and click on the Worlds tab, go down to IW Team 02 and that'll be the link to our world. We are Team 2. Okay, great. Perfect. Alright, so before I turn it over to my team, I'd like to say a little bit about myself, so please follow me into the biography room, which is just up ahead, the only other open room. And if you can see my laser pointer pointing into the room, that's our bio room. Alright, so my name is David, and I'm the college mentor for Team 2. I'm a sophomore at the University of California, Irvine, pursuing a dual major in mechanical and aerospace engineering. Last summer I had the chance to work on the actual James Webb Space Telescope sunshield at Northrop Grumman, which is the prime contractor. I've also worked on electronics for an instrument flying aboard NASA's future Solar Probe Plus mission. 2 years ago I was a participant on the winning team, and last year I mentored a team for this challenge. Now I will turn it over to Team Arctic Innovations to introduce themselves.
Hello judges, my name is Jacob Lemler. You will see my bio and picture if you look at the wall closest to the lobby which you just came from. As you will hear quite often in the next 3 minutes, I am a 10th grader at the Downingtown STEM Academy. I am one of the debate team captains at STEM, a winner of Best Delegate at the Penn State Model United Nations Conference, as well as a recent national qualifier in the entrepreneurship competition in FBLA. In the future, my goal is to become a lawyer. I will now turn it over to Zach.
Sorry everybody, I have to apologize. My avatar cannot be here right now due to a couple technical difficulties, but I myself am here on the chat. Now, my name is Zach Ing. I'm a 10th grader at the Downingtown STEM Academy as well. I spend a lot of my nights working at the local Dairy Queen, where I'm the shift leader. I also, when I have the money from my job, enjoy building computers and modifying cars with things like speakers, navigation, and backup cameras. I'm an active member of a club we have at the Downingtown STEM Academy called Kids Connect, which helps kids with childhood cancer. And I also spend a lot of my time doing home improvement. And if we turn your attention to the wall, you have Joey Cottingham's.
Hello everyone, my name is Joey Cottingham. I'm also a 10th grader at the Downingtown STEM Academy. I'm a member of a product development team at Inth Solutions, which is where I work. In my free time, I enjoy playing around with small electronics and building computers. I also like messing around with other computer science topics. Thank you. Now I'm going to be handing it over to Sam.
Hello, my name is Samantha Camp, and like my other teammates, I'm a sophomore at the Downingtown STEM Academy. I'm an officer in many clubs at school, including Future Business Leaders of America and Challenge Club. In my free time, I'm a nationally ranked equestrian, and I'm also a volunteer junior firefighter. With being a firefighter, I go on different medical calls, such as cardiac arrest calls, which you will understand the importance of later. The school that we all attend, the Downingtown STEM Academy, is the third high school in the Downingtown Area School District. This school accepts 100 students from each of the other two high schools, based on a lengthy application process. At the Academy, we follow the International Baccalaureate curriculum, and we will be eligible for our IB diplomas at the conclusion of our senior year. Our school is also ranked #1 in difficulty in Pennsylvania, and it's #8 most rigorous and challenging high school in the Northeast region, which was in an article by the Washington Post. Our team name is Team Arctic Medical Innovations because of our spin-off, which we will unveil later, is related to the medical field. Next, Jacob Lemler will be talking to you about the problem.
Hello everyone, it's me again. Just before we continue, I would like to let you know that I am currently suffering from a concussion, so if I stutter over a couple of words, I'd like to apologize for that right now. Now if you follow the Jacob L avatar into the next room, you can see our problem. Today our main problem is death, and that is about people dying too early due to loss of blood circulation. According to Manny Ning, MD, blood circulation can be the cause of death in many different situations, which include but are not limited to cardiac arrest, stroke, brain stroke or aneurysm, gunshot wound, or other injury. If you look at the slides on the right of your avatar, you'll see that over 93 deaths a day are caused by guns in the United States. Every year in the United States, 326,200 people have cardiac arrest with a 90% fatality rate. And the total deaths each year in the United States due to lack of blood circulation, which include all of the things I said earlier, are over 1,600,000. Our device, which you will see later, will be able to function effectively because it will be able to save not just that 1,600,000, but we hope in the future many more hundreds of thousands of lives. I'll now turn it over to Zach to talk about the tools we used.
So on the back of the space wall, or the window wall, we have the tools used. So most of our tools that we used were digital. We used PCs and Macs to access these, with the exception of a camera. We used a website called Pixabay for our free royalty images, Google Hangouts in order to collaborate across coasts, NIA Universe, which is the program we're all in right now, Google Chrome for all of our research and all of our images as well through Pixabay. Firefox and Firefox FTP were crucial programs in order to upload all of these images that you're seeing displayed. Google Slides is how we created these images. Google Docs is how we collaborated all of our information and wrote all of our research out. Enver 2017 is the 3D CAD program that we used. CAD stands for Computer Aided Design, that we used to create our 3D models. And ACCU Trans is how we converted those models that we made from Inventor 2017 onto a workable format for NIA Universe. Now I'm going to turn it over to Joey.
Now, if you follow me down to the end of the hallway, we'll discuss the criteria and constraints. Now, the first of these is that we had to design this with only 4 people. We had to design this with only 4 people, which became a problem when many of our close friends wanted to join and wanted to share ideas with us, none of which that we could take into consideration. It also had to be done completely by high school students and manufacturable, seeing that we wanted to sell this as a product. We also wanted to have this have a positive impact on society and also be safe for the user as personal constraints. Now, if you move around the corner with me to our brainstorm ideas, our first idea is the backplate drone / UAV concept, which it uses the backplate from the James Webb Telescope, uses the alloy that was used in the creation of this backplate. Now, this specially designed alloy is extremely strong and is extremely durable, which will allow drones to be repaired instead of replaced where you would expect replacements. This cost the government massive amounts of money, seeing that the MQ-9 drones, which is one of the most popular drones by the United States government, cost them roughly $13 million per single unit, meaning that this could lead to millions of dollars saved by the United States taxpayer. Some negatives of this brainstorm: that absent our mentor David, we know very little about aeronautical engineering. Another problem with our idea is that drone strikes often kill lots of citizens due to poor intelligence in bombing populated areas, which can be shown in recent actions by the United States government. Now, these obviously do not check off our 2 constraints, which are not to leave a positive impact on our community. Now, if you move to the end of the hallway, you'll see our second brainstorm idea. Our second brainstorm idea is a suspension chamber / crowd, which is a spin-off of the crowd core technology in the James Webb Telescope. Now, this suspension chamber integrates the crowd core technology from the James Webb Telescope. This device would induce hypothermia, lowering the metabolism of the patient. This would possibly save hundreds of thousands of lives each year, seeing that cardiac arrest is a massive killer in developed countries such as in the United States of America. The variety of different applications would lead to a positive impact on society, which obviously checks off one of our criteria. This device, however, could possibly kill the very patient that we are trying to save. But if in this situation, saying that this would only be used in situations that were dire, I think that risk is okay. Now I'll hand off to Sam to discuss our last spin-off idea.
Please direct your attention to the wall directly across from the drone idea. So this spin-off of the James Webb Telescope uses the heat shield technology developed for the telescope in order to insulate an underground bunker. This will protect the inhabitants of the bunker from extreme cold, warmth, or extreme levels of radioactivity. One of the major weaknesses of this design is that the heat shield mainly works for rays of sun, and since it's underground, there's no rays of sun. It will also cost a large amount of money to produce, and the limited market will make it hard to make a large enough profit off of this idea. Next, Zach will take you to the next room.
If all of you would follow the avatar straight to the next room. So the selected design that we chose was the cooler spin-off, also known as the suspension chamber. Now, we have a couple YouTube videos by our 3D model, which I don't want you guys to click on, because due to simplicity, for simplicity reasons, we are going to explain these videos instead of having you all individually view them. So when there's a massive loss of blood or lack of circulation of blood in the body, 2 tasks must be completed to save the person's life if they cannot be operated on immediately. The first objective is to lower the body's metabolism, so there's less need for cells to consume more material. The second objective is to cool the tissue in order to preserve it. The suspension chamber uses cooling technology developed for the James Webb Space Telescope to cool the body effectively, preserving and lowering the body's metabolism, so that the body is preserved and can be operated on in the near future. Now I'm going to hand it right off to Joey.
Now, moving on to the engineering and design aspects of the suspension chamber. Now, the suspension chamber works by sending compressed compound, which is a propane nitrogen-based compound, through copper tubing that the patient would be laying on. This would cool the patient through heat transfer. Once this compound has gone through all the tubing, it will be compressed back into the same storage tank where it will begin the process once again. At the exact same time, a second tank will be releasing the compound, which will be released into the chamber itself. This compound will similarly cool the patient from the top. When the heat of this compound rises, it will rise to the top of the chamber where it will be compressed back into the storage tank. This compound will then repeat the process again, similar to the other process. We use the copper tubing because it's easily cooled metal, allowing for a very effective transfer between the compound and copper tubing and the human body. Now we use a laminated glass to create a cover over the chamber. Now I'll hand it off to Jacob. He will discuss the medical and scientific aspects of the product.
Okay, I'm going to go into more in depth on what Zach just said. So to be specific, what the body has to be cooled to is normally the body is 98.6 degrees Fahrenheit. The body for this to work would have to be between 40 and 55 degrees Fahrenheit. So that would mean that our compound has to be extremely cool. Now you might be wondering why the patient does not experience frostbite. This is for 3 reasons. Firstly, with the nitrogen in the compound, the nitrogen will act as a barrier between the dermis and hypodermis levels of the skin and the cold, creating a barrier from the frostbite. Next, the oxygen, which we will talk about later, that will go into the body, will prevent cell death, which is what the actual thing is, which is what frostbite is. Finally, the copper and aluminum alloys that we would use in our product are actually going to stop the frostbite from happening on the skin. Okay, I talked about cell death earlier. Now, the more scientific topic is called apoptosis, and that's programmed cell death. Now, this happens when the lack of oxygen to the cells causes the cells to die. And though we are cooling down the body, if we do not supply oxygen to the body, the cells would end up dying itself. This is why we use a mask to put oxygen into the person's body until they are effectively quote-unquote dead. At this point, we take advantage of the hydraulic needles, which we will place in the jugular and carotid arteries, in the neck, as well as the wrist and the waist, which we'll use to supply oxygen to the body. The oxygen will get to the patient's bloodstream using what we call blood oxidizer, which is just a repurposed ECMO machine, which is smaller, cheaper, and used externally instead of internally like a regular ECMO. A blood transfusion will also be on standby, which can happen through the hypodermic needles using the O-negative blood that will be supplied with every suspension chamber. Our product has many medical applications, as it can be used to save people who are suffering from cardiac arrest, stroke, or a brain aneurysm, as well as patients who currently have massive blood loss, such as gunshot victims, which leads to this military applications. This device could be placed in ambulances and hospitals, which will give critical patients more time to arrive at a hospital or to have a surgeon or an OR open. When soldiers are shot in the battlefield, it is sometimes hours before they receive medical treatment from a qualified doctor, and a suspension chamber would give them more time. We are currently working on designing a more portable, compact version of this system that would look like a backpack. It would cool a patient's blood and then put the blood back into the body, effectively cooling the entire body by using the body's natural circulatory system. One thing you might have been saying to yourself is that this kind of looks like an ECMO machine, but you have to remember two things. One, in the ECMO, the body is still technically alive, you're just bypassing the heart and lungs, while in our machine, all bodily systems get shut down. Second, the ECMO machine has to be brought to the actual patient, and it's much harder as it is heavier and needs a lot more actual assistance. And for one single ECMO procedure can cost as much as $150,000, much too expensive for a normal person to talk about. I will now turn it over to Joey to talk about our actual 3D model of the suspension chamber.
Now moving over, you can see our suspension chamber model. As you can see, it's much like you would expect, with our two tanks being on the side and then the chamber being on the top, is sitting on the copper tubing. Some of the strengths and weaknesses of our design are that this device could save many lives and has many different use cases. It could fit in a truck and has potential to be struck down to a smaller form factor that could be more like a backpack size. However, we did not have the time to develop a product like this and the time to research a product like this, so sadly, at this current time, we only have this rather large device to show you. By our standards, it's very expensive, it will weigh a lot due to metal construction, and will also have a chance of killing the patient. Without this device, however, you would die for sure. In the future, we hope to make a suspension chamber that is more inexpensive and also more portable, so it will sell to a wider market. Now I'll hand it off to Sam.
Okay, so now if you could direct your attention to the 3D model of the James Webb Telescope. So a little background on the James Webb Telescope. The James Webb Space Telescope is an international collaboration between three space-exploring giants, including the National Aeronautics and Space Administration, NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. The James Webb Space Telescope will be the most powerful telescope ever launched into space. The cryocooler is necessary on this telescope in order to cool it and all the scientific instruments so that they can work efficiently and effectively. It also eliminates random noise electrons in order to convert infrared light. One of the strengths of the James Webb Telescope is it will allow astronomers to see the undiscovered parts of the universe that were not previously accessible. Also, the James Webb Space Telescope will be able to utilize the biggest mirror ever sent up into space. The main weakness of this telescope is that it's incredibly expensive to build and set up. Another weakness is that it must be launched into space and it is colossally large. Now Jacob will talk to you about the cost to manufacture our design.
If you follow me into the next room, what you will see our market plan and manufacturing research. Our design is very expensive as it includes many very expensive materials. I'll go through them quickly. The compressor, which we are calling the cryocooler, will cost right around $400 for a normal person to possess, such as one you could buy at Home Depot. If we were to use the actual cryocooler, this price would jump up exponentially. Copper tubing and all, we calculated the cost a little over $850. The aluminum alloy frame, as aluminum alloy is an expensive material, will cost a little over $32,000. Liquid containers to hold the liquid nitrogen and blood would cost right about $600. The tempered glass for the cover costs a little over $2,000. The ECMO, the small ECMO machine, will cost around $37,500. Oxygen tanks, a little about $380. The oxygen delivery tubing is $1,500. Surgical tubing is around $171. Hypodermic needles are very cheap, and bags of blood of O-negative blood is $687 according to Paoli Hospital. This brings the total price to about $77,000. Now our target market is 4 branches. The first and most obvious is hospitals, clinics, fire stations, and ambulance companies. The hospitals and clinics can have suspension chambers on standby if a patient is crashing or needs help or needs a specific doctor or medicine that's not available. Ambulances and fire companies, as well as the hospitals, can put suspension chambers in the back of ambulances in place of a gurney that can keep the patient alive for longer as they are transporting them to the hospital. Military. For the soldiers that get injured, as I said earlier, it can take hours. If they have a suspension chamber, when the soldier is waiting for a doctor, he or she can be put in the suspension chamber to keep them alive. The third market is private clientele. Many very rich clienteles would like to stay alive longer, and many of them are older people. If they are having a stroke, heart attack, seizure, etc., the chamber can know this and close up and put them in the suspended animation and call 911. This can save them their lives and can also make us more money for research. Finally, disaster relief. Red Cross, FEMA, World Vision, all organizations which could utilize our product to save countless lives. We would sell these products at cost to these organizations, as will not only save lives, but get our company very good PR. Now I'll turn it over to Sam for the rest of our marketing plan.
Okay, so the main customer of our product will be governments. This is for the main reason of our product being relatively expensive, and the amount one would need to be effective would cost so much that the governments are the most viable clientele. If we were selling to the military, we would have to look at the U.S. military first and foremost. But with the consent of the U.S. government, we would not hesitate to sell to U.S. allies, including the UK, Canada, Australia, Israel, and many others. We would also be able to sell to more local governments, such as cities, for them to put in the government-run hospitals, ambulances, and clinics. Cities have the resources, especially if the program would be federally subsidized, to buy a substantial amount of suspension chambers. If the city itself could not afford, we would go to the state to try to sell the product. Just take our local city of Philadelphia, which annually has a health budget of over $1.3 billion. We would also target big for-profit hospitals. Becker's Hospital Review says there are at least 50 for-profit hospitals in the U.S. alone that have over 370 beds. These hospitals would start to lose a lot of money if they did not. Distribution plan. To distribute and sell our product, our company will hire a team of sales associates to specialize in each type of buyer. There will be a sales associates for military purchases, hospitals, and EMT units. Buyers will be matched with a sales associate through an online website where they can directly call the company. Then, Arctic Medical Innovations will directly sell and deliver the product to the consumer or purchaser. Our pricing and positioning. So we, Arctic Medical Innovations, will price a suspension chamber at approximately $100,000, so its cost is not unreasonably high in order to make it more accessible. The goal of this product is to save lives, not just make money. Therefore, EMS units and small hospitals must still be able to afford this product. Next, Zach will talk to you about the skills we gained during this NASA project.
So one of the big skills we gained was time management. We had to manage a lot of our time due to our rigorous school and to complete all the parts of this project. We also had to work around with and match our group schedules due that we all had very different things to go, things going on in our lives. Group crowd is important in these projects because without each other we wouldn't be able to do this. Ingenuity is also a very crucial tool to succeeding in one of these projects as well. We had to use the Kyro cooler and spinning it off and coming up and brainstorming all these ideas was incredibly important and the backbone of this entire project. Now, all these slides are on the window wall. Now, advice that we'd give to some future OPSPARCers or competitors in this project is set benchmarks for yourself. Everything is so much easier if you set benchmarks for yourself. You set a little before you know you can do them, and then even if you go over, it's okay, but setting benchmarks is a great way to keep on task. And remember, all work and no play makes Jack a dull boy. Now, what that means is you gotta have fun. Without having fun, there's no point in doing anything. But having fun is incredibly important to having these, and relaxing is as well too. You don't want to you don't want to be overwhelmed by everything, and relaxing is super important to be able to do and operate well. Now I'm going to hand it off to Joey to wrap up.
Thank you for taking a time out of what I can only expect are extremely busy schedules to see all the hard work that we've put into our project. We hope that you guys have enjoyed yourself in World 2. We'd also if you would not mind, would you please put in your rubrics any advice that you would have for any future presentations that we would have put on. I would greatly appreciate that. Thank you. Now I would open the floor to questions.
Will you please turn off your mic? Thank you. Are there questions from NIA first?
Hi guys, this is Chris Jones from the NIA. One question I have is, of the costs you looked at for your solution, how much of those are sort of the cost to initially build the system versus the recurring costs each time you use it? And as a related question, have you thought about the costs to develop the system that are in addition to the manufacturing and operating costs?
So the actual cost and products, if we're not looking in bulk, is around $77,000, and if we're selling it, we're going to sell it at $100,000. Cost to manufacture in bulk, we think that if we look at the byproduct and we look at the bulk product in total, that $77,000 per product, if we're selling in bulk, will actually be the price that it would cost us to manufacture. Now, if you're talking about looking at prices per use, we can see that the price per use is going to be drastically lower than any competitor, including the ECMO machine, because the only price that would be needed to be reoccurring in our machine are twofold. The first one would have to be the actual compound, because after a certain amount of time, about 3 years we estimate, you would have to buy more nitrogen propane compound. Also, the blood, if you have to have a blood transfusion, you would have to buy more blood. But those are the only two recurring costs other than just regular electricity. So we can see this machine as being a very, very inexpensive alternative to a traditional ECMO machine, and also inexpensive for us to produce in bulk amounts, and we would like to sell this for only a small profit in order to keep going with our own research to try to make this machine smaller.
And so I guess to get to the second half of the question, what about the costs to do the research and development to get the system ready to manufacture?
So we would like to hire a professional engineer to do most of the research and development for this, as none of us are professional engineers. We only know the basics of this, and we'd like to hire more medical and engineering professionals. But out of the University of Maryland, they are doing a lot of research currently in suspended animation. So we would like to partner with the University of Maryland and their research team to go with our own research team in order to make it a better collaboration, as we can just use their products and their research into our own research, which is what we already did. But most of this research is already done. All we would have to do is live testing, and to do that, the only cost is the cost of getting, I hate to say it, but live test animals, including rabbits and mice, to test our actual cryocooling technology. We also think we might underestimate the cost, but we have not done a full cost analysis, as we do not have the resources currently to do that.
Okay. So another question we have here at NIA is, if a medical professional or somebody in the field was using this system, how would they make the decision on when somebody was injured enough to need to use this system? And then just to clarify, how cool do you reduce the body's temperature when they're in the system?
Again, this is my field, so I know how cool we have to go. We have to go, according to the University of Maryland, between 40 degrees and 55 degrees Fahrenheit in order to induce suspended animation. I'm also now going to turn it over to Sam and Zach to talk about the first part of your question.
So, the candidates who would be viable to use the suspension chamber would have life-threatening injuries such as major blood loss or cardiac arrest. So 9 out of 10 cardiac arrest victims die, so therefore it would be a good idea for any patient suffering from cardiac arrest to be placed into the suspension chamber.
So another thing is that we would have to, or the cryocooler would be used when it, so the cryocooler would have to be used, or the spin off the suspension chamber would have to be used when there's an excess amount of people in the hospital. So in cities like Chicago, you have a lot of gun violence, and so you can have massive amounts of people in the hospital and overcrowded suddenly, and so people, when they'd be prioritized, they would have to put in the cryocooler or the suspension chamber. So that would be an example.
One major example is that what hospitals use now in major situations, such as major loss of life situations, it's called a tag system. What you have is you have red, yellow, green, and black tags. Black tags are people who are DOA, dead on arrival. Now, red tags would be the people that are prioritized. Those are the people that have immediate loss of life injuries, people who are at major risk. So those are the people in these major situations who would be prioritized to go into the cryocooler. If not all the cryocoolers take up the red tags, we would move on to yellow tags, which are moderate life-threatening issues that could be solved in a matter of hours. Therefore, and green tags would be the least of our priorities, and most likely they don't have life-threatening injuries, so they most likely would not have to even use the cryocooling technology.
And if the hospitals were understaffed, this would also be very crucial, because if there's not enough people, they can just use the suspension chamber. We can have trained nurses and nurse practitioners operate with this machine.
So once you've put somebody into the suspended animation and then you're ready to treat them, how long does it take to bring them back from suspended animation?
Sorry, you're cutting out. Could you repeat?
Sure. So once the patient has been placed into suspended animation, how long does it then take to thaw them back out for once they are ready to receive medical treatment?
Currently, we don't have the actual research to know how long exactly it would take them to go from a 40-degree Fahrenheit temperature back to the standard 98.6 degree temperature. They would be operated on immediately, even if they're not at the correct temperature, as it is still possible, according to the University of Maryland, to operate on them. From the research from the University of Maryland, it should take only 15 to 30 minutes for them to go back to their regular temperature if we are using blankets and other heat sources to help heat up their body. But what we do know is that they're only able to stay under suspended animation for a maximum of 10 hours before the oxygen fails and the apoptosis starts to occur and their body actually does start to permanently die. So they can only stay on for a maximum of 10 hours, but we do not know specifically yet how long it would take for them to thaw out, as you put it.
Okay, thanks. I don't think we've got any more questions here.
We have a few questions here at the NASA Goddard Space Flight Center. Brooke?
Hi, this is Brooke from Goddard. Quick question. When you have a scenario where you have multiple gunshot victims coming in and you're bringing them in and out of their cryo floor, how easy will this be to clean up in between patients? How are you going to make sure that this is easy for your nurses to sanitize?
So our machine can be easily hosed down, but other than that, when they're in the machine, the extreme cold temperatures that are actually the DNA and the blood and the bodily fluids are done that are experienced by them actually makes it so that it's sterile, because these extreme temperatures make sure that the blood cannot transmit between patients, but it can easily be hosed down in between, or even just using a washcloth can easily just be cleaned down.
Also, something I learned from my part-time job is we have sanitizing water, and sanitizing water you can just quick spray down, and it's a really easy plumbing thing to install, and you can it's great for sanitizing and killing bacteria and sterilizing any machine.
Now, how our machine is designed that the actual surface that the patient is laying on has gaps in the surface that will allow the blood and other bodily fluids to leak through, where you set up a different, a sort of just tub where all these liquids could gather, making it easier and making it so bodily fluids would not all just combine in a huge puddle on top of the system. Thank you. Any more questions?
No, I think those are all of our questions here at Goddard and NIA. I'm sure from both camps, we really want to thank Team 2 for all of your hard work. It's very evident you've put a lot of time into your thinking and your research and your brainstorming. David, can you get us?
Thank you guys so
Yep.
much.
So if you go back to the tabs window on the left and click on Worlds, and you scroll near the bottom is RW-IW, which is the public world. Bottom about six or seven from the bottom. Thank you for your time.